So in today's lesson, we're going to continue our conversation around current electricity and circuits. But before we go into some deeper concepts with respect to current electricity, there are some terms that we need to make sure we have a good understanding of. And the first one of those terms is electric current. And so I'm going to start with relating electric current to something that you're a little bit more familiar with, I hope, which is the current that might flow in a river. So when we're talking about current in a river, we're really just talking about how quickly water molecules are moving from one spot to another within the river. Well, so in essence, this is a rate, right? We're looking at the number of water molecules that are moving in a given amount of time. So in the same way, electric current describes the flow not of water molecules, but of electric charges from one point in a circuit into another point in the circuit. So if I were to zoom in on a picture of, zoom in on a wire and look at it and in sort of larger frame, and I were to look at a specific point in the wire, so imagine this cross section.
On call 356, please.
Then what I would be looking at is I would be looking to see how quickly electric charges are moving through that cross section in a given amount of time, and that would allow me to measure the rate of electron flow. That is essentially what electric current is. It's a measure of the rate of electron flow through a circuit. So there's some interesting symbols that we use. So you may remember that, I'm going to relate this to something else that we've seen before. So you may remember in the chemistry unit we looked at density, and density had the symbol in the formula D, and density was equal to mass divided by volume. And so we used the symbols M and V to represent mass and volume respectively. So if we were looking at an equation that involved current, the symbol for current in the equation would be I. Why? I don't know, but it is what it is. Okay? Now, the unit of measurement that we use to measure current is called the ampere, and it has the symbol A. So some of you may recognize the word amps, and so that's really just a short form for the unit of measurement for current, which is the ampere. So to relate this back to something you understand, so in density, to calculate density, we used units of grams and milliliters, say for example, and those were the units that we used to measure density. Okay, so for example, I might talk about a current, okay, having a current measurement of 2 amperes, right? In the same way that I might measure mass as being 2 grams. But I think we have a pretty good idea about what 2 grams would sort of look like. But what would 2 amperes look like? Well, 1 ampere is really just a measurement of a huge number of electrons, 6.2 times 10 to the power of 18 electrons passing through a specific point in that wire per second. That's huge, right? So if I were talking about 2 amperes instead, I would be discussing really the fact that there would be 2 times 6.2 times 10 to the power of 18 electrons traveling through that circuit or that wire per second. It's quite huge. So I found this animation that I think sort of explains the differences between currents of different sizes pretty well. So the difference between a circuit is carrying a large current is you would see far more charges passing through a certain point in that wire compared to a circuit carrying a smaller current, right? Fewer electric charges moving through. And so that's really just what current is. So I'm sure you can imagine that there are certain trades people or maybe engineers or maybe just a homeowner that you may want to measure the amount of current that's passing through a specific circuit, right? So like in your household or something like that. And so the way that you do that, the instrument used to measure the amount of current flowing through is called an ammeter. So you can see that this prefix am sounds sort of like an ampere, and so the ammeter is the instrument used. And so here's an example of an analog one, and here's an example of a digital one. So we have both of these in class, and when we come to class tomorrow, or hopefully whatever we get to meet, we'll be able to see how these function. So similar to like a thermometer measuring temperature, an ammeter is simply measuring the amount of current flowing through a circuit. Now, since we've been talking about circuit diagrams and circuit symbols, I think it's important that you understand, if you are connecting an ammeter, how to connect it properly, and also what that's going to look like in your circuit diagram. So we always connect ammeters in series, which means that there's only going to be a single pathway for those electrons to travel. So if we're wanting to measure the current in a specific circuit, then we need to make sure that the current is actually passing through the ammeter if it's going to be measured, right? So, you know, my electrons, my electric charges would be moving through the wire, through my load, in this case it's a light bulb, and then passing through my ammeter in order to kind of record what the rate of electron flow is. So as I said in class, hopefully we'll have the opportunity to practice using an ammeter. For now, what I'd like you to do is I'd like you to take a look at the homework section on page 557 and take a look at questions numbers 1 and 3 to complete for homework. I'll be posting the section from the textbook on the Google Classroom post so that you can access both the text section and the homework questions themselves. I'll also be posting another video at the end of my 2 lessons that may kind of solidify your understanding and give you a different perspective on current. So be sure to save some questions for me, and as you complete your homework or watch the video again, and I'll be happy to help you out when we get back together.